Hi, everybody. Thank you for being here. It's kind of early for me for a Saturday, and so I appreciate everyone who's here. My name is Janine Cloud, and I've worked for Family Tree DNA for almost 12 years. It'll be 12 years in July. And Michelle asked me to talk about why an mtDNA, something other than just autosomal DNA, since pretty much most everybody knows about autosomal DNA at this point. I am a native Texan, fifth generation Texan, and have deep roots in the state. And so it's always exciting to me to be able to talk to folks who are in Texas and have that connection. So we'll just go ahead and get started because I'm going to be honest with you. I was tweaking this and tweaking this and tweaking it. So I'm not 100% sure exactly on the timing on it. So I want to make sure that we get everything in. Just a quick reminder that this program is protected by copyright. If there's anything that you want from it, if you like a copy of the slide deck, you can shoot me an email. I'll have my email at the end of the presentation. So let's get into the meat of it. We're going to talk about, we're just going to go over a brief DNA review. We're going to look at the different kinds of DNA tests, and then we're going to look at some tools that we have and group projects. Now, I like to start out on occasion by saying what DNA testing can and cannot do. Now, DNA testing is not going to give you an instant downloadable pedigree. Would be nice, and that sounds kind of like a ridiculous thing to say in a way, except it's based on a real comment that someone made on social media at one point after saying that she had tested with Ancestry, and somebody asked her about her pedigree and she said she didn't know. They hadn't given it to her yet. So just to clear everything up, it's not going to give you that instant downloadable pedigree. It's not going to instantly provide you with specific locations where your ancestors lived either. It's going to give you some information about where they came from, but we're not looking at a GPS program here. And it's certainly not going to automatically qualify you to register for a Native American tribe. That's something that we get calls about all the time. I remember early in my employment, people would be calling up and saying, you know, I'm gonna prove that I'm Indian so I can get money from the government. And I'm like, yeah, that's not how it works. I'm a registered member of the Cherokee Nation, and I can absolutely tell you that's not how it works. It's not going to tell you what Native American tribe you're from, even if you do have results that show Native American ancestry. It's not specific enough to tell you which tribe you're from. Whoops, sorry. And it's also not going to qualify you for Israeli citizenship under the law of return. I remember asking Max Blankfeld, one of the founders of Family Tree DNA, about that, because he and Bennett Greenspan, who this image bears a striking resemblance to Bennett Greenspan, but it actually is from Adobe. I was shocked. But I asked him about the law of return, and he just looked at me and went back to what he was doing. It's like he didn't even grace it with an answer. So those are some of the things it can't do. But DNA testing can confirm suspected family relationships. It can also rule out unrelated lines that saves you time, energy, money. And I'm going to show you a really good example of that later in the presentation. It provides you with leads that are genetically related, which is kind of connected to that previous one. And it shows you those origins and overall ancestral percentages where your ancestors did come from. And last but certainly not least, it connects you with people who are interested in your genealogy. I'm sure all of you know that, you know, I've had that glazed eye look when you start talking to people about your genealogy, and they're like, okay, she's at it again. And how about those Astros? So let's start back at the beginning, and maybe a little basic for some folks, but I like to start at the beginning because some of these things may be are pertinent to what we're talking about later on, and it may be something that you haven't thought of in this way. A deoxyribonucleic acid, it's no no mystery why we just call it DNA, because that's a mouthful, is made up of bases or nucleotides that are connected in a double helix, and they're called base pairs. So if you're around genetic genealogy very much, you may hear the term base pairs, and that's what we're talking about, these pairs of bases that form that ladder. And there's a forward and a reverse strand that are involved with it. So, it goes both ways. Now, there are 4 types of DNA. We have mitochondrial DNA, which is inherited by everybody from their mom. Everybody has mitochondria because it's part of our powerhouse of our cells. And so since everyone has mitochondria, you have mitochondrial DNA. It always comes from mom. Whether you're male or female, it always comes from mom. Autosomal DNA is the one that's most commercially available. It's 22 pairs of autosomes and 1 set inherited from each parent, which is why 23andMe is called 23andMe. And this is what you get from both of your parents. And they look to this Texas girl kind of like mosquito larvae, but they're actually are autosomes. And we have the X DNA, which is inherited from mom and inherited from women get 1 from each parent. And then there's Y DNA, which is inherited from dad, and it's paired with the Y chromosome from mom. So men only have 1 X chromosome, women have 2 X chromosomes. That's not to be confused with mitochondrial DNA. Now, there are also 2 types of DNA mutations. Now, in this context, mutation simply means a change, a variant. It doesn't have any negative connotation to it. It doesn't mean that that a mutation can't have a health-related issue with it. But at mtDNA, we don't get into medical stuff with our genealogy program. We're happy to rent them the FDA an office in our office building, but would prefer not to get involved with their paperwork. So we only deal with genealogy. So even if there is something that shows up in your results that involves health, we're not qualified to say anything about it. Now, the first type is called an STR, or a short tandem repeat. We use those in Y-DNA tests. Every form of DNA has them, but we only use them in Y-DNA tests. They are used occasionally with autosomal. That's actually what CODIS is. Your law enforcement uses those autosomal STRs. And then we have SNPs, or single nucleotide polymorphisms. They're also known as variants. So it can get confusing sometimes. We have mutations, variants, SNPs. Those all mean the same thing. And that's used in all 3 test types that we do. And those 3 test types each has their advantage and their disadvantages. They have specific uses that you would apply them for. So autosomal DNA. Now, okay, so I said we were going to talk about Y and mtDNA, but in order to demonstrate to you the beauty of using Y and mtDNA, I have to tell you what autosomal DNA can and can't do. And like I said, it's inherited from both parents, and it's randomly recombined, randomly mixed together from the DNA that they each inherited from their parents. And then they also include ancestry informative markers that give you those ancestral origins percentages. Now, you'll see those called ethnicities, but that's really a misnomer, because ethnicity is a term that implies culture, and DNA knows nothing about cultural information, only about where you came from, where things came from. So I generally try to say ancestral origins instead of ethnicity, but that's what we're talking about. In the early days, it used to be the pie chart. Where's my pie chart? Now, why would you want to take an autosomal test? Well, you're looking for recent relationships, because it is the DNA that you have, you got half from each parent. It's going to get you those more recent relationships, birth families, siblings, etc., closer relatives. If you're looking for Y and mtDNA test candidates, that's a big use of them. And then if you want to see where the areas of the world where your ancestors potentially originated, and I say potentially because the percentages that you're provided are with reference populations, and there are a limited number of reference populations. So your ancestry may be from something adjacent to what's on your chart that you see, your results that you see. And the limitations are that like siblings only get 50% from each parent, but it's not necessarily the same 50%. That does mean do test siblings, because you can pick up things from one sibling that you might not get from the other, but you're not going to be able to get a full picture just by testing one sibling if you have a sibling to test. Because each generation only gets half of what the generation before had, that amount that you inherit divides out with each generation. So it only goes back about 5 to 6 generations. And so each generation carries less of that DNA. And by the time you get back about 7 generations, it's less than 1% that you potentially inherit from each of those ancestors. And in many cases, you don't get any from some of those ancestors. So if you're trying to reach a specific ancestor who is back several generations, you may or may not be able to reach them based on autosomal DNA. And it's not inherited in exact ratios. So that in addition to being randomly recombined, nature is not neat and tidy. If you take nothing else away from this talk, I would want you to understand that nature's not neat and tidy, and that you cannot apply logic, reason, and mathematics to random recombination. It just doesn't work. It's called random for a reason. And again, random recombination is the name of the game with autosomal DNA, and that's why it is challenging, is because you got to figure out who came from where, which comes from which ancestor. And if you're like me and you have like colonial ancestry, or if you have an endogamous population where cousins have married repeatedly, that can sometimes be really difficult to do. Now, xDNA, like I said, males inherit mom's DNA, and it's typically a combination of both of her X chromosomes. Again, not neat and tidy. One may be a whole one may be mixed together, or they may both be mixed up from the other X chromosomes. And I mean, I'm sorry, it may be that one may be a mixed up, or it may be a whole one. It just really depends. Now, females, we get one from each parent, one from dad that he got from his mom, one from mom, and sometimes it's passed down whole. Most of the time, though, it's recombined, but you don't know until you get in and look at it. So it's kind of challenging. It does rule out some people, though, so it can be really rewarding for using it. This data is included in the autosomal test. Does have random recombination. So you can't use formulas to try to figure out what came from whom. It has to be with a specific algorithm that helps pull that apart. Now, mitochondrial DNA, both men and women can test, since everyone has mitochondria that they inherited from their mothers. Now, that's really important. And again, don't confuse this with the xDNA. They're not the same thing at all. Now, the direct maternal ancestral origins, so your mother's line, where they came from, is reflected in the haplogroup, which is a label that is assigned based on the markers and where they came from. And you can connect with matches who share a maternal ancestor at some point in history. And that can be kind of challenging because it can be pretty far back. Now, mitochondrial DNA does not divide or recombine, so it's not mixed together with anything from anybody else. It's only that mother's line. If you have somebody that shows up as a match to you on your mtDNA test who is from your father's side of the family, then you know that at some point their mother and your mother have a connection, because it's only that mother's line. So why would you take an mtDNA test? Well, if you're tracing a maternal line, whether it's your own or a collateral line and you get somebody else to test, because it doesn't divide. It goes back farther than that 5 to 6 generations. In fact, sometimes it goes back far enough that it's difficult to determine who how those matches match you. And if you're trying to find maternal connections that are not supported by records, for instance, just recently, Judy Russell did a program on, confirming who one of her maternal ancestors was by using a number of mtDNA tests to confirm. In burned out counties, there were no records for it. So she was able to do that, but it took a lot of tests. Now, if you're trying to confirm areas of the world where those potential ancestors originated, it can be mtDNA can tell you where, but you remember that it's not your mother's side of the family. It's only one of those maternal lines. So it's only where your mother's line came from. I've had a number of people who are like, oh, but my mother's family was from Sicily. Okay, but maybe that side of the family was, but where did that mother's mother come from? Because we're going back hundreds and even thousands of years. So the limitations with this are that it doesn't tell you anything about male ancestors. Men can take the test, but it's not going to tell you anything about your mother's father's mother or your father's mother's mother. It's just your mother's mother, or whoever tests mother's mother. It only traces that direct maternal line. There's nothing paternal about it at all, ever. And it changes really slowly. So your matches could be as close as a sibling or a parent if you test your mom or your siblings, or it can be 20 generations away. It just really depends. Now, you may need to test more than one person to isolate the specific line. In fact, you probably will need to test more than one person to isolate a specific line. And like I said, with mtDNA, it may be difficult to find out how those matches are related to you. It's going to take a bit of work there. The most recent common ancestor may be generations ago. And as I said, you're probably going to need more than one person to solve a specific puzzle or prove a specific lineage, unless you're only looking for generalities. Updates to the family tree, the mtDNA haplotree, which is like a huge pedigree chart of your maternal ancestry, of the human maternal ancestry, will be coming later this year. And with that, we're hoping to have a lot more information available with your mtDNA results, because the current tree was created with only about 6,000 sequences, and it hasn't been updated since 2016. The organization that does that hasn't updated it since 2016. And so we're working on building our own tree based on the roughly, I think right now we have just under 500,000 or so, and we're working to get more and more sequences to be able to establish a more diverse and accurate tree. But again, no random recombination. It doesn't mix together with anything else. It's just your mother's lines. There's no confusion with that. Now, an example of a way that it's useful, my second great grandmother, on my dad's side, one of my lines there was full-blood Cherokee. Her mother's name was Tawny. Her name was Jane. And then my great grandmother, Mary Jane. And she had a daughter from her first marriage named Sarah. There's Sarah. And she had a daughter who had a daughter who had a daughter who turned up as a match to me on Ancestry. And so I wrote to her several times over a year to finally get her attention, because here's my line going back to that same ancestor. So I'm female, and goes through my dad to his dad. So mtDNA is not going to work there. It's not, Y-DNA is not going to work there. And it's a little far back for autosomal. My percentages show up as approximately 3%. And so that doesn't tell me much about any of those ancestors. But when I finally got cousin Janice, my second cousin once removed to test, it goes directly back to that full-blood Cherokee line, and I was able to get her to do mtDNA. She even paid for her own test, which is really cool because that doesn't always happen. And we were able to confirm that that haplogroup is B2, which is a native haplogroup. So I was able to say that even though the paperwork does say that she's full blood, I do know that her mother's line was native. Now, on the flip side, confirming not native, my son, his paternal grandmother has always said that her grandmother came from Spain. Her family came from Mexico. I can trace her direct maternal line into the 1800s in Nuevo Leon, Mexico. So it was obviously not her grandmother who came from Spain. It was a grandmother up the line who came from Spain. And so it's not uncommon when you're looking at people in Mexico whose families are from Mexico for their mtDNA to be native and the Y-DNA to be European, because the Spanish came in and it was the men who came over and got with the native women. But in her case, her mtDNA came out to be H3AP, which is connected with Portugal and the Iberian Peninsula. So it's quite possible. I've not been able to, we don't have enough information about this haplogroup yet to pinpoint it. I'm hoping that the update will do that, but it's definitely European. So it does lend credence to her story that her grandmother came from Spain. Now, I threw this one in because it's just really recent. It's actually not something I've done yet. Serendipity just threw this in. So I have a family finder match that came up that was like the perfect email that I got, where the researcher said, okay, here's the names I think we match on, here's the pedigree, here's the person that matches you, et cetera, all the great stuff. And I was able to look at the pedigree and see that this match is actually connection through my mother's father, so his sister's great grandson. So we have this match in a direct line up to my maternal grandfather's mother. So I know how he's connected. I know he's that cousin. So then I get my dad's brother tested, and I got his mtDNA done, and his line goes up, and who shows up but that same guy. So now I know that somehow my mother's father's mother's line and my father's mother's mother's line intersect, which kind of helps explain why I have so many both matches, people that are connected on both sides. Will I be able to find that connection? Well, how many tests will it take me? I don't know. We'll see. I'll keep y'all posted. So my Y-DNA, let's move on to Y-DNA. It traces your paternal ancestry, as I said. It's through both matching and haplogroup, and it can provide you with clues about an ancestral paternal surname. That's not always the case, but sometimes it does, and when it does, it can be really powerful. It provides information about where that line came from, and you can use a test called the Big Y700 strategically to determine that most recent common ancestor, the person that, where you're connected on that line. It also does not recombine or divide. So it's only your father's 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 line, and it doesn't mix any of those other people in there. It doesn't divide. So it goes back farther than that 5 to 6 generations that you can get to with autosomal DNA. And I'll show you some more, another example of this in a little bit. Why would you take a Y-DNA test? Well, ladies, unfortunately, we can't do it, but why would you sponsor one in that case? If you're looking for paternal ancestor, if you're trying to connect to that paternal ancestry, it can provide you with information that's not mixed together with anybody else. That's really very useful, especially when you have the kind of things that I showed you with the mitochondrial match, where they're connected on both sides of my family. Now, if you need to go back farther than that 5 to 6 generations, I show a great example of that in just a minute. If you're trying to connect with those connections that are not supported by records, if you're trying to make a leap that isn't there on paperwork, or that you haven't been able to find the paperwork on, and you're trying to get a clue where to find those records, at what time frame you're looking for. And of course, if you want to discover areas or confirm areas of the world where those ancestors came from, it might be surprising. For instance, I had a gentleman come up to me at one conference with his notebook this big of his research on his Norwegian ancestry, and he'd traced his father's family back to the family village in Norway. And then he did a Y-DNA test, and he came up haplogroup J, which originates in the Middle East. So that was pretty confusing. And once he determined that it was accurate, that it wasn't a fluke or a lab error, he started doing research, and it turns out that there was a ship from the Spanish Armada that had wrecked across the fjord from the village, and the survivors went into the village. And so his direct paternal ancestor, while all his other ancestors were Norwegian, that's direct paternal ancestor was probably from Spain or Portugal, and he was able to start pulling strings that way, starting with the ship's manifest. He would never have known that had he not taken a Y-DNA test. Now, the limitations are only men can test, and because of that, it can be challenging to find someone to do the test who has that direct line. It doesn't tell you anything about female ancestors, and it does go back hundreds of years. So it's not necessarily going to tell you about your most recent ancestors, although it can in some places. That direct paternal line, but it cannot distinguish between brothers in recent time frames. So for example, if you were trying to determine which of a set of brothers was the father of a recent relative, say, uncle, great uncle, something like that, the Y-DNA would not show that because it doesn't mutate quickly enough for that. You would have to use autosomal tests for that. But it can help parse those lines going back hundreds of years. Again, no random recombination, which is hugely valuable when you're trying to parse those lines apart and get straight back on that paternal line. Now, remember I said that there were two kinds of mutations. Now, with Y-DNA, we use YSTRs. That was the first test that was offered direct to consumers back in 2000. mtDNA was the first company to sell DNA testing direct to consumers, and it was a Y12. It was 12 STRs. Now, the bases that we talked about in the beginning, that G, A, T, and C, those repeat in various sequences, and it's at specific locations that are mapped on the chromosome, on the Y chromosome, and then it's counted how many times that particular sequence repeats. It could be, AGGTC, it could be any combination, and you count the number of times that it repeats, and then those are compared against the database of the repeats, and then it's displayed as a number, and then those form patterns, and that's how we get that STR matching. So you're able to see those connections on that level of, that you share a paternal ancestor at some point. What to expect with it? Well, you may not have many matches. It just depends. Even with some of the more common haplogroups, there might not be that many matches if it's not well tested. If you have matches, it may not be that easy to find out how that they're related to you, even if you have a lot of them. And you may need more than one person. And that's going to be the theme here. You may need more than one person, just like you need more than one census record and more than one probate record to figure things out. You may need more than one person to test to solve a particular problem or find particular information. And if you rely on those lower level matches, you might come to some erroneous connections, because what objects in the mirror are closer than they appear is the exact opposite of this. STR testing, it gives you an idea of who's connected, but they may be more distantly related than you think. There's a tool that we have with that's called the tip calculator, which is a way of measuring the time. It helps predict the time to the most recent common ancestor based on those STRs, but you have to be careful, because it can only provide you with the amount of information that the STRs provide. And my finale in this will give you an idea of why you have to be careful with that. An example of a way that DNA testing can help you is, for example, cousin Frank Billingsley. He's a meteorologist here in Houston. I've been watching him for years, and he's an adoptee. He started out testing Y37, and Family Finder, I looked at the names on it and I was like, that's one of my family names, maybe we're related. His Family Finder results came in, and sure enough, we were. He got some strong surname hits, which again are on my tree, and he tested with some other companies, fished in all ponds, networked with some search angels, etc. Turns out his birth father had an NPE, so there was lots of confusion there. And then he found both birth parents, and he wrote a book about it. But what really gave him that string to pull to start with were his matches. So if you can see that the very first one was his father, who had a different surname, was not a Hensley. The next guy was adopted. And then all the rest of them, out of 49 Y67 matches, he's got 35 of them that are a variant of Hensley. So that's a pretty strong indicator that that's is his genetic surname, and it actually turned out to be, and we turned out to be, fourth cousins. Now, SNP testing, on the other hand, is a little different. It's a change at a single location from one base to another. Those bases that we talked about, it's not a sequence of them. It's just a change from one to the other at one specific location, and it gives correlates to a position on the haplotree. The farthest downstream of those SNPs, if you're testing a sequence of them, is called terminal, which is kind of a misnomer, but that represents a family line that's unique to your particular paternal family line. So when you're using SNP testing, you can expect that, depending on who else tested, that recent ancestor may be generations ago. You may need several testers to get that particular lineage, and individual SNP purchases and SNP packs are static. So like if you go in and say, okay, I've got my Y111 and I just want to get this SNP to see if I match this other guy, that's great. You may or may not match the other guy, but that's not going to change. It's only going to stay that way. If you do a SNP pack, you're only getting what's in that SNP pack. It's not going to give you any new information. It's only stuff that's already on the tree. Only Big Y is it looks for new SNPs. It looks for things that are not on the tree, and only Big Y has matching. The SNPs, right, just plain SNPs aren't going to give you matching either. Speaking of Big Y, what is it? It is a sequenced test. And by that, I mean that instead of going in and looking for a specific location, those locations like on the STRs and everything, it looks at everything along a section of the Y chromosome. It goes in and finds everything that's there, both things that are already on the tree and things that are unique to your particular line. It has STRs, and that helps you connect to those relatives. It includes the Y111 actually, as well as additional STRs. And then the SNPs to connect to those family lines, where it puts them on the pedigree, on the huge pedigree. There are over 500,000 SNPs on the Y haplotree now. And it's like a huge pedigree chart. If you look at it and you think about, if you look at the haplotree and you're like, oh, that's image over here is what the haplotree looks like. It looks kind of confusing, but if you think of it as a descendancy chart, then it becomes a little clearer when you understand that this arrangement is like, that's your lineages, only it's genetic instead of on paper. So what does it do? That all sounds great, sounds kind of confusing, but what does it do? Well, the first thing, the most important thing, is that it reveals SNPs that are unique to your branch, to your tester's branch, stuff that's not necessarily already on the tree, unless you're testing somebody really close. For example, I tested my half brother to get compared to my uncle, so that those SNPs would get matched and put on the tree. But in most cases, those SNPs are going to be unique and nobody else has them until somebody else comes into the database. Again, Y-DNA and mtDNA, both those haplogroups map migration paths. And so Big Y helps you look clearly at that migration path of your direct paternal line. It confirms that haplogroup. It makes the estimates more accurate than STRs alone. And it also gives information to build that haplotree, which gives us information about, humankind overall. And again, like it contributes to that research for human history. I don't know if any of you paid attention, but we only a couple of months ago, we participated in a test of Beethoven's hair. So we were able to, we have a bunch of people who now are able to connect to Beethoven via Y-DNA, those kinds of things. And then various populations, we're strategically testing specific populations all over the world where we can get them, so that people can connect to those areas that are not necessarily, the United Kingdom's pretty well tested. Central America not as well tested. So, we're trying to get that rounded out. So what do you expect with Big Y? Well, not all lineages are well tested. We have around 90,000 or so Big Ys in the database, which sounds like only a few, but overall, for the number of testers that are in the database, the Y database, it's enough that most people get significant information, but not everybody. For example, I have a guy who's doing some testing in Switzerland, and not too many people in Switzerland have tested, so they don't have as many matches at this point yet, and not as much branch definition. Now that time to most recent common ancestor may be hundreds or thousands of years ago, depending on who's tested, or it could be 100 years or less. For example, with my brother and my uncle, it shows up as being like late 1800s. So it can be very close depending on who tests. Again, you will almost certainly need several testers to solve a particular problem. And then you get to use the Discover tools. What are the Discover tools? We have a page called Discover, and you can just go to FamilyTreeDNA.com and discover.familytreedna.com, or if you have a test, you can sign in, and the button's here, and it provides you with a lot of information. I'm not going to go through all of these because of time, but it does give you information about the haplogroup and the countries, some connections and things like that. And you can actually, even if you've tested it at, say, 23andMe and have a haplogroup, you can go to Discover page and plug that in and find out some information. Discover.familytreedna.com. But the really cool thing is that once you have, like if you've done Big Y, it provides you with information on what you got. So you can tell, when that most recent common ancestor was. You can see, who the most recent notable connections were. We're continually adding notable connections. So for instance, my paternal ancestors in shared an ancestor with Ernest Hemingway about 1750 BCE. So yeah, a pretty long time ago, but there's a connection back there somewhere. And then there's some of the scientific details if you're looking for that. If you're looking for the science behind it, there's information on that as well. In this particular case, like I said, this is my paternal line, and you can see where it says the mean of the time to most recent common ancestor for this specific SNP is 1888. And that's actually when my grandfather was born. So it's pretty accurate for that. Some important caveats regarding this once you get into it, just in case you do your big Y and you want to use Discover. It is in beta status, so there are things that will change over time with it, sometimes radically, sometimes just a little bit. It is not integrated in the database, so it doesn't automatically ping the database. Everything is on an upload basis, so it doesn't automatically update. So when you get your results, it can be a couple of weeks before that information makes it into Discover. We typically do the uploads every week, unless our R&D people are traveling, and then it may be a little bit longer. And those, whether it's a new haplogroup or branch placements, et cetera, may take about 2 weeks at times. One of the cool features about Discover, though, is that it recommends some projects. It suggests projects based on your results and on stuff that information that group project administrators have suggested. And it allows you to select some projects where you can see, who else, if there's other people in there that belong to the same haplogroup. Which brings us to group projects. And so what is a group project? It's led by volunteer administrators. They're usually looking to further their own research, although we do have some who manage projects that they're, that have either been abandoned or that they're asked to help out with that may not have anything to do with their own research. They're just helping out. But overall, it's usually for their own research. They're free to join. Some do have prerequisites, though. You might have to demonstrate that you have a connection to a particular family line. You might have to demonstrate that you have ancestry from a particular region. If you're joining a haplogroup project, you're going to need to have taken the test that goes with that. Some of these groups are from family organizations. Look at the Cloud Family Association sponsors the Cloud one, and some of them actually came from other companies. Like when Ancestry sold off or closed down their YU database, they had some groups there that they just moved them wholesale over to us. So some of them actually have a fair amount of history there. And overall, it allows the administrators to analyze those DNA results and to help you out with your information. We have several types of projects. We have the surname projects that help explore a surname overall. We have some of those can be pretty specific. It can be, just they're only looking for the descendants of a specific ancestor with that surname, and some of them are the whole looking at the whole surname. Haplogroup projects are either mtDNA or Y-DNA, and that look at the evolution of that group. Geographic looks at specific regions. For instance, Finland is a very large, it's like our second largest project. There's like 10 times more people in that than in the town that I grew up in. And in Brazoria, Texas, there's like 20,000 people in it, and it shows the Y-DNA and mtDNA of that, which is it's a dual geographic project. And then there are Family Finder autosomal projects where admins are able to use tools to look at the relatedness among family members. So an example, and this is my big thing here regarding Y-DNA. This is my big story. I'm really excited about this, that I have such a great example of the power of Y-DNA here. I started researching my paternal lineage years and years ago, and pretty much anyone named Cloud is going to try to connect to William the Immigrant Cloud. You know, everybody's got their immigrant, the immigrant ancestor. He was born in Wiltshire, England in about 1621, and he was a Quaker, came over to Pennsylvania. They, in 1682, he had 6 sons, 5 who lived to adulthood. So that's plenty of sons, and many of those sons had sons. So there was a good number of people to test. Well, my line, I can go back to James Monroe Cloud, who was born in 1838 in Georgia. I know his father's name was Isaac. I know that because it's on the family card. His wife Martha was Cherokee, and so he has his name listed there. He was actually enrolled in the tribe for a short time as Cherokee by marriage. So it lists his parents' name, but there's, I don't know, something like 280 or something trees with Isaac Cloud on Ancestry, and none of them conclusively show one that I can say this is absolutely James Monroe Cloud's father. So I can get to 1838 Georgia, which is a little bit removed from 1621. And so I can't connect there. So that's kind of been my deal, is trying to get there. So, you know, I got my uncle to test, and you can see these are some of the 67 marker matches for my uncle. You can see that have William Cloud. So, you know, great. STR matches, you know, they're not that far off. They're only a few steps off, and they list the right ancestor. So I'm on the right track, right? And so here we have my brother, and then this guy right here is an exact match at 111 markers, but his name's Reinhardt. What the heck? So we did Family Finder to see if they were connected in a recent time frame, and nope, didn't match on Family Finder. So we're not talking about some recent misattributed parentage or anything like that. It's just, all right, so he's an exact match. Don't know where he fits with all the clouds. And then Big Y comes along, and we do Big Y testing, and that STR genetic distance doesn't always hold up. So here's my line right here, Cloud Knights, which is my half brother's name. It's a long story. And then this branch right here, they have a genetic distance of 1 and 3 at Y111. This one, genetic distance of 2. And here's the guy with the exact match at 111 markers, genetic distance of 0. And he's 4 branches up the haplotree. I wouldn't have been able to see that without Big Y testing. Then Discover comes along, and we have a tool in there called the group time tree, which shows the lineages, the SNPs in order, and it takes the subgroupings that the administrators put in and shows the relationship among that subgroup. So I selected those subgroups, and here's my guy right here. Here's my line. There's James right there, and there's Reinhardt all the way up there. And if we look at the when you hover over these on the actual program, I don't do a live on it because you just never know what's going to happen with the website. So I always do a slide instead of trying to do a live demo on it. But when you hover over it, we've got 1614 right here. So that's probably, we're pretty confident that that's William, because that's pretty close to 1621, right? And you see that he's got these descendants right here have that William the immigrant listed there. So you can see that line going there, and then here we are, and they don't intersect at William. Here, my line goes back to about 1493 before we intersect. So I could have been bumping up against that block, that roadblock, that brick wall forever, because it was never going to happen. It was never going to connect. So you remember in the very beginning when I said what DNA testing can and can't do? One of the things it can do is to rule out matches, rule something out so that you're not wasting time and money. And that's what this did is, as now I'm not going to spend hours and hours and hours trying to connect James to William, because it's not going to happen. I have to go back from William, farther back from him, follow his tree up to get that connection to come down to my line. And Reinhardt, he's way up there. They connect at the same place. And so, you know, it was several hundred years ago that connection happened. And so we may never know how he connected with the Clouds, or we might find it out, and it just depends. But that wasn't, like I said, it wasn't a recent misattributed parentage. So how can you get the most out of your results? In Y testing, by the highest level that you can afford. If that's not big Y, you can keep adding on. We store the sample and you can upgrade until you get there. mtDNA, if you've tested mtDNA, make sure you have the full sequence. If you only have one, HVR1 or HVR1 and 2, which when you look at your results, you'll be able to see that. Go ahead and upgrade to the full sequence, because that's going to give you the most complete information. Make sure you update your profile, including your earliest known ancestors. Make sure that when you put in that paternal ancestor, that it's your father's 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 line, not the earliest person that you know on that side. Just making sure it's that father's father, even if it's just your grandfather, just that father's 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 line. When you do the maternal ancestor, make sure it's your mother's 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 line, not some, the earliest known person on that side. Make sure it's that straight line again, and then put up a tree, even if it's just a basic tree with just your main branches, some kind of a tree up there, so that that other people can look at it and help connect. In other words, try to be the match that you want to see. Consider testing family members. I've tested a lot of family members and gotten a lot of information from testing various cousins and things like that. The stories I could tell, but that's a whole other presentation. And then, of course, join a group project and participate in a group project, because the information that I got about connecting to William Cloud was only possible through the group project and through enough people testing to be able to show that separation in those lineages. And so it does take a lot of people to be able to get to some of those sometimes. Make sure you're testing the right person. If you're trying to connect to a male ancestor, follow his descendants, get that direct male descendant, the son of a son of a son. If a female is in that line at any place, Y DNA won't work. Try again, look for a different one. If you're trying to find a female ancestor, follow her descendants to a child that's the daughter of the daughter of the daughter. If the tester can be male, but if there's a male along that line anywhere in that lineage that you've drawn out, mtDNA won't work. Try again, look for somebody else. And I can't emphasize that enough, that you may even have to just write it out, or look, draw it out, draw pictures, because it's very easy. I see it all the time at conferences when people are trying to get, find out who they need to test, is they'll be like, okay, well, they get to like a grandfather and then they're trying to go to his mother, or, and it just doesn't work that way. You have to go directly. Use your matches as candidates. Remember my success with my cousin Janice. Use any database, search for ancestral surnames in all databases, and write to them. And like I said, make sure that when you write that letter, that it's one that you would want to get. Look for the tree, ask for the tree. Lots of people manage lots of kits at various places, so it's always good to say the two people that you're looking at, both the person that is matching and the person that's being matched, so that it's easy for somebody who looks at the email. I get people are always saying to me, nobody answers my emails. And then the emails that I get are like, okay, Ancestry says we're related. How are we related? I'm not motivated to particularly answer that. I'm not going to say I won't answer it, but it makes it a lot more difficult if you don't get enough information. And if you're lucky, they may have already done the test you need. Like if they match you at 23andMe or Ancestry or MyHeritage, they may have tested with family tree DNA, and they may have already done a Y or an mtDNA test. And maybe they have done some Y testing, and you can help them upgrade or something like that. It can happen. And just a reminder, DNA tests are tools. They're like census records, probate records, etc. They're not magic wands. So tools imply work. And I think sometimes people get really discouraged because they expect that DNA testing to be this magic wand that's going to give all this great stuff. And sometimes it can. Sometimes you get those eureka things that happen. But more often than not, you're going to have to do some work with it, just like you're going to have to dig, just like you dig through all those records. Father's Day sale through tomorrow, 12:59 p.m. Pacific time. So 2 a.m. Houston time. mtDNA and Family Finder is on sale. So just available on the website. If you've tested with mtDNA, you can sign into your kit. Be sure to sign into your kit if you're going to order something else, if it's for yourself. If you're ordering for someone else, do not sign into your kit, or it'll be added to yours, and you don't want that. So I thank you for your attention. And that wasn't too bad over the time. And my email address is there if you have any questions. You can shoot me an email at janinec@ftdna.com.
Thank you so much, Janine. Really appreciate this. This was amazing. Are there, Cindy, are there any questions in the chat that maybe Janine could answer easily?
There was one on if there was a syllabus available, and I said that it was recorded and would be available after this meeting. So any other questions?
I don't have a syllabus, but if you would like the slide deck, you can shoot me an email. Again, that was Janine, JANINEC @ftdna.com, and I'm happy to share the deck with you.
Anyone else have a question?
I thought it was a great presentation. Thank you so much.
Oh, thank you.
Hello, can you hear
Yes.
me? If you've never done any DNA testing, which one of them would be the first one that I would do?
I would say it would depend on what you're trying to find out. If you are only looking for your mother's line or a maternal ancestor, then
Yes.
mtDNA might be the right one.
Which one?
mtDNA, mitochondrial.
Okay.
If you're looking for a paternal ancestor or a male ancestor, then Y-DNA could be the one, but you would have to get the right person to test because you wouldn't be able to do it. If you're just starting out and you're just exploring, then an autosomal test would be the best place to start because that's going to give you more recent connections. And then you can kind of get comfortable with the idea of it and then go from there once you've figured out exactly, who you want to connect with and how you're going to get there.
Okay. All right. Thank you very much.
Mm-hmm. The number one question to always ask is, what am I trying to find out? What are my goals? What am I trying to get from the testing? And that's going to tell you which type of test that you want to take.
Well, Janine, we really appreciate your presentation today. It was fabulous. Thank you so much.